Alright, in the last video we were talking about how to solve a system of two non-homogeneous linear ODE by the method of variation of parameter, right? So this is continue from there, but here instead of a pair of system of two linear ODEs, we will consider a single second order non-homogeneous differential equation. Okay, so let's start with the theorem. What this theorem says is, if the function p, q and g are continuous in an open interval I, and if y1 and y2 are the fundamental solution of the homogeneous form, okay, then the particular solution of the non-homogeneous equation, the same equation with the non-homogeneous term on the right hand side, is y sub pt equals to negative y1t integral y2t gt divided by the Wronskian of y1 y2 plus and y2t and integral y1t times gt divided by the Wronskian and integral of that. Okay, and what is the general solution? The final answer will look like yt equals to c1 y1 plus c2 y2 plus the extra term, that is the particular solution. Okay, let us do an example. Let us solve y double prime plus qy equals to 3 sine 3t. This is gt, right? So to solve this equation, first of all we need to find out the complementary solution, meaning the solution of this left hand side equals to 0. That means we ignore the right hand side first and then solve it to find out the complementary solution. Okay, so here if you just do the method that we did, so what you do is you find out the eigenvalue like lambda square and then plus 9 equals to 0, right? If you solve it, you will get eigenvalues plus minus 3i, and then you use the formula to find out the solutions y1 and y2. So if you do that method, let's do solution. The solution of the homogeneous, you get y1 equals to cosine 3t, and you will get y2 equals to sine 3t. If you solve like that, the method that I just mentioned, you will get y1 and y2 are the two solutions. So what is the complementary solution? Hence the complementary is y, let's say yc. Okay, let's denote that yc, c1 y1 plus c2 y2, right? How does that look like? c1 cosine 3t plus c2 sine 3t. Now the problem is finding the particular solution, right? To find out particular solution, we use the formula above. To find particular solution, okay, to find out the particular solution, we first find the Wronskian, right? First find Wronskian, right? So how do I find out the Wronskian? Wronskian is w equals to, what you do is you do y1 prime and then y2 prime, right? That's how do you find out the Wronskian for the second order equation, right? Second order ODE. So if you do that, what do you get? Oh, basically it is the determinant of that. Okay, so to find out the particular solution, we first find the Wronskian given by the determinant of the we first write the solution and write the derivative of the solution, right? So how would that look like? That will look like, let's plug in those values there. It will be cosine 3t and then minus the derivative is negative 3 sine 3t, right? And then sine 3t, and then this will be 3 cosine 3t, right? If you find out the determinant, how that look like, it will be cosine 3t times 3 cosine 3t will be 3 cosine square 3t, right? So it will be like 3 cosine square 3t plus, because negative times negative will be positive, 3 sine square 3t, right? If you take 3 out, you will get times 1, right? Because it is cosine square a plus sine square a, like. So it is basically the Wronskian is 3, which is non-zero. So y1 and y2 are basically the fundamental solution. Does that make sense? Okay, so let us find out the particular solution using the above formula also. So ypt, we use that formula, right? Let's write down negative y1t, and then that will be, let us, since this is a number, not t here, this is just a number, I'll pull that out from each of those. Okay, so what do I get? I got negative cosine 3t. So I will get negative cosine 3t divided by negative cosine 3t divided by 3, and then what is the integral? Integral is y2t gt, right? So what is the y2t? y2 is sine 3t, and then gt is basically 3 tangent 3t dt, right? dt, and then plus you will get sine 3t over 3, and then integral, you'll get 3 cosine 3t times, and then you get tangent 3t, and then dt. You see that? How did that 3? I wrote that 3 out. I mean, you could write 3 here, okay, or here, wherever you write. So it will cancel out, right? That 3 will cancel out. And what do you get there then? So basically, you got negative cosine 3t, and then you got sine 3t. Let's write down tangent into sine over cosine. Sine 3t over cosine 3t dt, right? And then plus sine 3t is there, integral cosine 3t times sine 3t over cosine 3t dt, right? You cancel that cosine 3t and cosine 3t. So the simplified form look like this: negative cosine 3t, right? Integral sine square 3t over cosine 3t dt, right? Plus sine 3t integral sine 3t. Basically, I forgot to write the parenthesis everywhere. Just think that it is there. So dt, right? Now we need to find out this integral. Can you tell me how do I find out this integral? You're right. So what you should do is you should take cosine 3. Basically, there are many ways you can do that, okay? So what you can do there is you can write this as 1 minus cosine square t, and then change that into the simplify that, okay? So how do I find this integral? So let us simplify a little further. Negative cosine 3t. You can write this like 1 minus cosine square. It's sine square, right? So you can write 1 over cosine 3t, and then minus cosine square 3t over cosine 3t. That's what you get, right? And then dt is still there. And then plus sine 3t. Tell me, what is the integral of sine 3t? That will be negative cosine 3t over 3. That's what the integral look like, right? So So how do I find the integral here is negative cosine 3t, right? This is basically secant 3t minus, let us find out the integral separately, cosine 3t, right? That's what it looks like. This is integral, and then plus, that will be minus 1/3. You can write sine 3t times cosine 3t. Does that make sense? So I'm just simplifying that, right? So let us find out what is the integral of secant. Do you remember what is the integral of secant? So integral of secant is, let me write down what we have there. Negative cosine 3t is still there. So parenthesis, the bracket, you can write integral of secant 3t is basically 1/3 natural log of secant 3t plus tangent 3t. That's what the integral of secant 3t is. And then minus, what is the integral of cosine 3t? It is 1/3 sine 3t, right? Close. And then minus 1/3 sine 3t times cosine 3t. That's what it looks like. This is the particular integral. Okay, so what is the final solution then? So this is yp. Okay, you can simplify. Basically, you can distribute this negative cosine 3t with that thing, and then distribute this with the second term, and then write that one. Actually, you can change this into 2 cosine a sine b, right? That will be like 1/6 sine 6t. You can write that way too, but that's fine. So what is the general solution then? General solution is yt equals to c1 y1 plus c2 y2, right? And then plus ypt. All of them have t. Alright guys, let us do another example, that is y double prime minus 2y prime plus y equals to e to the t over t squared plus 1. So this is the non-homogeneous part, right? So to solve this equation, first of all we need to find out the complementary solution, meaning the solution of the homogeneous equation, right? Meaning you set that equals to 0 and then solve this one only. But how do you solve the homogeneous equation? You first find out the eigenvalues. To find out the eigenvalues, what you solve is you solve lambda squared minus 2 lambda plus 1. This is like lambda squared minus 2 lambda plus the quotient of that is 1 equals to 0. If you solve this, you will get lambda equals to 1 and 1. That is repeated eigenvalues, right? In case of the repeated eigenvalues, from the theorem that we discussed in the class, the solution is, let's denote the complementary solution by yct. It is c1 et plus c2 t e to the t, right? That implies y1 is e to the t and y2 is t times e to the t. That's what you get. So to find out the complementary solution, what we need to do is to find out the particular solution, what we need to do is we need to find out the Wronskian W. So that is Wronskian is y1 and then y2, two solutions, and find the derivative, right? So e to the t e to the t, derivative here. And then you find out the determinant of that, you get e to the twice t. Now to find out the particular solution, actually you use the formula we have here, right? So the formula will give you negative y1 is e to the t and y2 times g over Wronskian, right? y2 is this, g is this over that, right? And Wronskian is this term, plus y2 times y1 times gt and divide by the Wronskian. That's what you got. And see, e to the t is e to the twice t, right? E to the twice t divided by e to the twice t. So you cancel out that. Similarly here you cancel out. What is left is negative e to the t and then times t over t square plus 1. But what I did here is I multiplied and divided by 2 just to make sure that the derivative of the bottom is on the top. The derivative of t square plus 1 is twice t. In that case, the integral will be the natural log of the denominator. That's why I just multiply and divided by the 2. Similarly, there is t e to the t outside and 1 over t square plus 1. So when you integrate, you have e to the t negative e to the t over 2 times the integral of this part is natural log of the denominator, and plus this is as it is, the derivative of integral of 1 over t square plus 1 is tangent inverse t. So what is the final answer then? The final solution is C1y1, C2y2. These are the complementary solution, plus the particular solution is ypt, which is that value.